So, in this video, I'm going to be talking about Gabriel's horn. And what's interesting about Gabriel's horn is that it has an infinite surface area and a finite volume. And we're going to mathematically show this. So to start, it's going to be Gabriel's horn is going to be on the x-axis, so just draw the x-axis, kind of, and it's going to start at 1, so 1, and go to infinity. And the radius of the circles that make up Gabriel's horn are described by the function 1 over x. And so with this information, we can start calculating the volume using the disk method. And so using the disk method, the volume V is going to equal the integral from 1 to infinity of pi times 1 over x squared dx. So we can just bring the pi out front. So this is going to be equal to pi times the integral from 1 to infinity of 1 over x squared dx. So the antiderivative of 1 over x squared is the same thing as x to the negative 2. Antiderivative of x to the negative 2 is going to be negative 1 over x. So this is equal to pi times negative 1 over x from 1 to infinity. Okay, let's keep going. Equal to pi times negative 1 over infinity. That's just going to be 0. Minus negative 1 over 1. Okay, so that's going to be 0 minus negative 1, which is going to be positive 1 times pi. That's going to just be equal to pi. So the surface area is a little bit more difficult. The general formula for surface area is the integral from a to b of 2 pi times f of x times the square root of 1 plus dy dx squared dx. So that is the formula for surface area. We can apply this to Gabriel's horn and find the surface area. So the surface area of Gabriel's horn is going to equal the integral from 1 to infinity of 2 pi times 1 over x times the square root of 1 plus the derivative of 1 over x is going to be negative 1 over x squared. So negative 1 over x squared, and that's going to be squared dx. So looks pretty nasty, but if we think of it this way, the square root of 1 plus negative 1 over x squared, this is always going to be greater than 1, and so this is going to be increasing the y values of 1 over x. So we can compare this to another simpler integral. We could just take the integral, so this is going to be greater than, just bring the 2 pi out front, 2 pi times the integral from 1 to infinity of just 1 over x. So we could just ignore this because this is just going to be increasing the y values of 1 over x. And if this right here goes to infinity, then we know that the surface area also goes to infinity of Gabriel's horn. So let's do that. So the antiderivative of 1 over x is just going to be the natural log of x. So that's going to be 2 pi times natural log of x from 1 to infinity. Okay, so the that's going to be equal to 2 pi times natural log of infinity, okay, plus or minus natural log of 1. Okay, the natural log of infinity is just going to be infinity. So since this is infinity, and natural log of 1 is just 0, this whole thing is just going to be infinity. So pretty interesting. We've just shown that this shape right here has an infinite surface area and a finite volume. Seems like a paradox. It's pretty cool.